Okay, let's unpack this. We've got quite a stack of sources here, all focused on linear graphs, coordinates, plotting points, the basics, really.
Exactly. And our mission, I think, is to cut through all that information and, get to the essential understanding. How do we actually locate points and draw lines in this 2D space?
It's kind of like a map for numbers, right? We're diving into some foundational concepts here.
Totally. And it all starts with the coordinate plane. You've got the two main axes, the horizontal one, that's the x-axis, sometimes labeled XOX prime, and then the vertical y-axis, YOY prime.
Right. And here's where it gets really interesting. These two lines, they're not just any lines. They're number lines, and they're perpendicular. They cross each other at a very specific spot.
That's the origin. We usually call it O. It's the 0 point for both the x-axis and the y-axis.
Okay.
And the flat surface, the whole area that contains these axes, that's what we call the coordinate plane. It's our working area.
Got it. So you have this plane, this grid. How do you pinpoint one specific location? Like, give it an address.
Yeah, good way to put it. You use just two numbers for any point on that plane.
Two numbers, okay.
The first number is the x-coordinate. It's also called the abscissa, though you hear x-coordinate more often. It basically tells you the horizontal distance from the origin, left or right.
And the second number?
That's the y-coordinate, or the ordinate. Tells you the vertical distance from the origin, up or down.
So together they form the coordinates, written like xy, right? Abscissa first, then ordinate. Like the example 2 next 3 from one of the sources.
Exactly. 2 next 3 means you go 2 units along the positive x-axis.
To the right.
To the right, and then 3 units parallel to the axis, but in the negative direction.
So down pinpoints that one spot.
Precisely.
Yeah.
And, there are some special cases that are useful to remember. Any point on the x-axis itself, its y-coordinate has to be 0. So it looks like x0.
Makes sense. No vertical distance?
Right. And similarly, any point on the y-axis has an x-coordinate of 0. So 0, y, y. And the origin, where they cross.
Vertically.
You got it.
0, 0.
Okay, so these axes, they don't just help us find points, they also divide the whole plane up, don't they?
They do, into 4 distinct parts, or regions. We call them quadrants.
Quadrants, right. And the signs of the coordinates, the plus or minus, tell you which quadrant you're in relative to the origin.
Exactly. Think about the top right section. There, x is positive and y is positive. That's the first quadrant. We write plus L plus...
Top right is plus L plus. Then, if you go counterclockwise, top left.
Top left, you've moved left of the origin, so x is negative, but you're still above it, so y is positive. That's the second quadrant plus...
Makes sense. Then bottom left.
Down there, you're left and down, so both x and y are negative. Third quadrant, Salem.
And the last one, bottom right.
You're right of the origin, so x is positive, but below it, so y is negative. That's the fourth quadrant plus Elm.
So like that other example from the sources, 5, that was 4. You see positive x, negative y, boom. You know instantly it's in the fourth quadrant. It's like a quick check. It is. It's a very neat system. And this ability to plot points based on these x-y coordinates, well, that's fundamental. It lets us actually see mathematical relationships.
Exactly. Which brings us to things like... linear equations in 2 variables, the ones that look like x plus y plus c equals 0, they describe some kind of relationship between x and y.
And here's a really key takeaway from these sources. When you plot all the possible pairs of x, y that make a specific linear equation true, what do you get?
You get a straight line.
Always a straight line. That line is the picture of all the solutions to that equation. It's a visual representation.
Which is incredibly powerful for solving problems.
Right.
If you have 2 of these linear equations and you graph both of them, the place where the 2 lines cross, their intersection point.
That point. Its coordinates, x, y, are the solution that works for both equations simultaneously. You can literally see the answer.
So cool. It connects the abstract algebra to a concrete picture.
That's the beauty of it. Understanding the system gives you that bridge. From equation to picture, and from picture back to the numbers.
Okay, so wrapping this up, we've sort of unpacked the basics from these sources. The coordinate plane, the axes, the origin, how coordinates work like an address, the 4 quadrants based on signs.
Yeah, and crucially, how all of that allows us to plot points and then graph these straight lines that represent linear equations.
It really forms the foundation for understanding so many graphs you see everywhere, weather charts, economic data, you name it.
Absolutely. It translates numerical relationships into something visual, something you can often understand much more intuitively.
So what does this all mean for you listening? Well, next time you encounter a graph, Just remember this underlying structure. Think about how it started with this simple XY grid.
And maybe consider this. What would the graph of a really simple relationship look like? Say, y equals x. Where would that line go on the plane? And maybe reflect on why having that visual line is often so much more insightful than just staring at the equation itself.